Hey guys, so sorry in advance about the quality of the audio in this video. I don't have my microphone on me and I'm just using my headphones microphone, so it's not super great. That being said, I don't really think it should affect the quality of the math being done. So let's just keep on trucking for it. So here we have a homogeneous differential equation. It's not the same one as on the last midterm, just because that one was pretty tricky, and I wanted to start with something that was a little more easier to stomach. So the first thing we're going to do is we're going to divide everything by x squared. So y prime is equal to y by x plus e to the y by x. From here, what we're going to do is we're going to say that y is equal to vx. Subsequently, v is equal to y by x, which is something you're maybe more familiar with seeing. And y prime is equal to, well, it's the product rule of this, so derivative of the first times the second plus the derivative of the second, which is 1 times the first. So derivative of x is just 1, so that's why that shows up like that. So from there, we're going to substitute all that back in. So v prime of x plus v is equal to v plus e to the v. We can cancel out this v, and we can cancel out this v, so that just leaves us with v prime is equal to e to the v is equal to, v prime x is equal to ev is equal to dvx by dx. So we're just going to rearrange that so that we can actually integrate. So what that boils down to is a dx by x, which is going to be equal to a dv by e to the v. So that becomes ln x. Let's pop an integral sign on there so we don't lose marks. So that means we have ln x plus c. I'm going to keep the c on this side just to make my life a little bit easier, is equal to negative e to the negative b. So we're going to make this a little simpler. So we're just going to change this left-hand side. So that's going to be minus, and that's going to actually stay plus, because again, c is arbitrary. And we'll just take out that. So we know that that's actually equal to e to the negative v is just 1 over e to the v. So that shows you how we're going to be simplifying that. So let's take the ln of both sides. Actually, let's first make sure we rearrange properly. So e to the v is equal to 1 over negative ln x plus c. So that's how that rearranges out. What I'm going to do now is I'm going to take the ln of both sides. So v is equal to ln 1 over ln negative ln x plus c is equal to y by x. So therefore, y is equal to x ln negative ln x plus c by 1. So that's how you get solve a homogeneous differential equation. If I went a little fast, I'm sorry. Let me just give you the once over here. So we take this x squared, because it's on the y prime, and we divide the whole thing out, which leaves us with this. Because we're seeing this y by x here, it makes sense that we're going to make a substitution of v is equal to y by x to make our lives easier. Subsequently, y is equal to vx, y prime is equal to v prime x plus v. You can verify all this stuff on your own. So once you plug this and this into this equation right here, so the substitution in the main equation. We're left with this, v prime x plus v is equal to b plus e to the v. Take out that b, make your life easy, and then you can rearrange so that all the dv's on one side and all the x's are on the other. I'll let you integrate, which leaves you with this function. And from there, you'll just be simplifying to get it back in terms of a y. So that's a homogeneous differential equation. Like I said, that's an easy one. I do plan in the future to upload a solution for the one on the test. Thanks, guys.